Today's lesson we're going to work on solving radical equations, and that's basically equations that include a radical symbol. So basically what we're going to do is if we have something like this, x plus 5 equals 7, and I want to solve this, I have to get rid of this the square root symbol. So to do that, what I would do is I would square both sides of this. Mathematically, whatever, we can do the same thing to both sides of the equation. That's still going to remain equal. So the square of the square root just cancels out, and I get x plus 5 equals 7 squared is 49. Then I subtract 5. Subtract 5, x equals 44. And that's that. And we should always kind of check just to make sure. 44 plus 5 is 49. Square root of 49 is 7. So that does work. So we're going to look at simple equations like this and then some more complicated ones. Okay, so from the homework tonight, the first one is this one here. This is number 1 on the homework. We have a square root symbol right here, which we have to eliminate. But before we square both sides, we have to deal with the 17. We have to isolate the square root symbol. So to do that, I'm going to subtract 17 from both sides. And then these cancel out, and I have square root of 2x plus 1 equals 3. And now to solve this, I need to get rid of this square root symbol. So what I'm going to do is I'm going to square both sides of the equation. And it becomes 2x plus 1, because the square root squared just gets rid of itself. And I have 2x plus 1 equals 3 squared is 9. And now I just solve this like a Algebra 1 student. Minus subtract 1 from both sides. 2x equals 8. X equals 4. We probably should check to make sure that works. If I put it in, 2 times 4 is 8. 2 times 4 plus 1 plus 17 equals 20. Let's just check to make sure. 2 times 4 square root of 8 plus 1 plus 17 equals 20. Square root of 9 plus 17 equals 20. 3 plus 17 equals 20. That is a true statement. 20 equals 20. There we go. That's correct. So this is our answer right here. Sometimes the problems get a little confusing. This one here is going to be a little more confusing because we have an x on the other side of the equation as well. But the principle is still the same. We isolate the square root symbol, and then what we're going to do is, that's what we have, equals x plus 1. That's the equation. What we're going to do now is square both sides. Now the problem with squaring, I got to square this. To square, I got to square the entire side of the equation. That's a common mistake from people. We tend to square the x and square the 1 without squaring the whole side of the equation. So it really looks like this. The left side's pretty simple. The square of the square root gets rid of it, so that's going to be 7x plus 15. And this side's going to be tricky because this one I have to basically do FOIL. X plus 1 times x plus 1. And I can say that's x times x is x squared. X times 1 is plus x. 1 times x is plus another x. And 1 times 1 is 1. So x squared plus 2x plus 1 is what the right side of the equation equals. So this will be x squared plus 2x plus 1. And what we've done is really change this square root problem into a quadratic problem. Now when we have a quadratic equation, we want to get the x squared, we want to get everything set to 0 so we can factor and solve or use completing the square or quadratic equation, whatever way is best fits it. We're going to try to factor if possible. So here I'm going to subtract 7x from both sides. That's going to be 15 equals x squared minus 5x plus 1, and now I'm going to subtract 15. So I have 0 equals x squared minus 5x minus 14. Now I can go through the steps of quadratic equation or completing the square. The easiest way to solve, if we can, is to factor. So we're going to try to factor this, because when I have 2 factors equal to 0, then one of them has to be 0. So factoring looks like this. To get x squared, it's going to be x times x. The last 2 terms, this one here and this one here, I have to multiply to 14 and subtract to 5. That's going to be 2 and 7. and then the bigger number gets the minus, whatever's here, and the other one's plus, and I can check that's going to be minus 7x plus 2x is minus 5x, and that works. And now what I'm going to do is, since I have two things multiplied together to equal 0, this times this, one of them equals 0, and it doesn't matter which one. So either x plus 2 equals 0, in which case x equals negative 2, or x minus 7 equals 0, in which case x equals positive 7. So I have two possibilities, but before I just say there's my answer, I want to plug them back into the equation. I'm going to first plug in negative 2. That would be then the square root of 7 times negative 2 plus 15, comes all the way to here, equals negative 2 plus 1. So this becomes, just go through the math of this, the square root of negative 14 plus 15 equals negative 1. And that's the square root of 1 equals negative 1. And that's not true. 1, because this is 1 equals negative 1, which does not true. This is not a true statement, which means this is not a solution. We call that extraneous. That's an extraneous solution, which basically is a solution to a modified part of the equation, but not the original equation. Now I want to make sure I try 7 to make sure 7 works. Sometimes none of the things will work. In this case here, let's see. Square root of 7 times 7 plus 15 equals 7 plus 1. The square root of 49 plus 15 equals 8. 49 plus 15, that's 64. Square root of 64 equals 8. 8 equals 8. That is true. So we do have one solution for this problem, 7. Okay, a little tricky thing there. It's important to check your answers after you do the math. Okay, I'm going to skip this one because that's a pretty basic one here. Well, yeah, you guys can do that on your own. Just so you know, the answer to this one would be, when you check your work, x equals 7 would be the final result answer. I'll let you work that one out. Number 5, this is number, this is number 4. I'm going to let you work this one out as well. This one is a little tricky because we end up with a fraction in our answer, but when we end up, x would be 74 over 3. And leave it in that form when you do that. The next problem we're going to work on is going to be number 5. I'll do this one with you. This one's a much trickier one, again, because we have the x over here. So we're going to, I'm going to rewrite this right now. I'm going to say that's the square root of 44 minus 2x equals x minus 10. And then the structure here would be to get rid of the square root sign. I square both sides. And don't forget, this squares the whole thing, so that's going to be 44 minus 2x equals, when I square x minus 10, that's x minus 10 times x minus 10. That's going to be x squared minus 10x, which is these two. Then these two is minus another 10x. And then negative 10 times negative 10 is plus 100. Or x squared minus 20x plus 100. So now when I factor this out, I got to set this equal to 0. So I'm going to go through the steps and add 2x to both sides. I have 44 equals x squared minus 18x plus 100. And now I want to get rid of the 44. So I'm going to subtract 44. So I have to get the whole thing to equal 0. When you have a quadratic, which is an x squared term, you want to set it all equal to 0. So 0 equals x squared minus 18x minus 56. And now I want to factor this out. And again, all that factoring you did in Algebra 1 is important. It makes life a lot easier in Algebra 2 and on beyond. So x and x give me x squared. Looking for numbers that multiply to 56, subtract to 18. Turns out that's 14 and 4. let's go back. Hold on, I'm sorry about that. This is not plus. This is supposed to be a plus because 100 minus 44 is plus 100. Okay, I was surprised. Sorry about that. Looking for numbers multiplied at 56 and add to 18, which is 14 and 4. Okay, so now, and they both have the same sign, which is both negative here. So I have two answers for this. Let's figure this out here. So either x minus 14 equals 0, in which case x equals 14, or x minus 4 equals 0, in which case x equals 4. And again, we have to check both of our answers in the problem. So first, let me do it here. First, I'm going to check 14. I have square root of 44 minus 2 times 14 equals 14 minus 10. So that's the square root of 44 minus 28 equals 4. That's the square root of 16 equals 4. 4 equals 4. That's correct. 14 is a correct answer. Now when we tried 4, I got the square root of 44 minus 2 times 4 equals 4 minus 10, and that becomes the square root of 44 minus 8 equals negative 6. Some people at this point could say we can't have a square root equal to negative, so I know that's not going to work. We can do the math of this if you want to. Square root of 36 equals negative 6. That's going to be 6 equals negative 6, not possible. So this is not a possible answer, which means this is not a possible answer. We call that extraneous again. All right, next problem here that I'm going to look at here is this one here. I'm going to let you work that one out to yourself. If you want to check your work, the correct answer is there's only one answer for that, x equals 25. Okay, the next problem we're going to look at is this one here. The difference here, it looks complicated, but really this is a cube here. So it's the same principle we had before, only instead of squaring both sides, we're going to raise to the third power, because the cube of a cube root will get rid of the cube root symbol. So I'm going to take this to the third power. Since I'm taking this side of the equation to the third power, I must take this side of the equation to the third power. So that becomes the cube of a cube root cancels, and I got x minus 16 equals 2 to the third. That's 8. 2 times 2 times 2. Okay, now I want to solve this, and I can solve this quite easily by adding 16 to both sides. And I got x equals 24, and I want to check to make sure that works. The cube root of 24 minus 16 equals 2. I'm just replacing the x with our answer, 24. And that becomes the cube root of 8 equals 2. So 2 equals 2. That checks. This is the correct answer. All right, I'm going to do a couple more problems here. I'll let you work this one out. Just remember that's the fourth power, so we're going to raise to the, that's with 1/4 power, or the fourth root, so we raise to the fourth power. When you do this work, you'll find that there is no solution to this. Nothing works. We get an answer, but it doesn't work. Next problem is this one here. Actually, it's not written that way on your paper. Let me fix this a little bit. On your paper, I think it's written like this. I'll copy it the way it is. It's the cube root, whoops. It's the cube root of 2x minus 5 equals cube root of 8x plus 1. I just mistyped that, sorry. So this is what we're going to have. So at this point, we basically have a cube root. We're just going to do the same thing we did in the last problem. We'll cube both sides. And I have 2x minus 5 equals 8x plus 1. And I solve this one, get all the x's on one side. I want my x's on the left side. You don't have to do it that way. Sometimes people like to work with positive numbers, but I'm going to do it this way. These are going to cancel, and I have negative 6x minus 5 equals 1. So now I'm going to go through the steps to solve for x. Plus 5 plus 5. negative 6x equals 6. And then we divide by a negative 6. X equals negative 1, and I want to check to make sure that works. So the cube root of 2 times negative 1 minus 5 equals the cube root of 8 times negative 1 plus 1. So that's the cube root of negative 2 minus 5 equals the cube root of negative 8 plus 1. The cube root of negative 7 equals the cube root of negative 7. And my first thought was I can't have a negative under a square root, which is true, except for this is not a square root. This is a cube root, so we can have negatives underneath there. So this is the correct answer right there. All right, the last problem I'm going to do is number 10. Number 10 is a quite complicated problem because we have square roots on both sides. Now, we're going to go through a similar process, only we're going to have a problem when we do this, because I want to get rid of this square root. The method to do that would be to square both sides. So I'm going to square this side, and I'm going to square this side. The left side, the square of the square cancels. That's pretty simple to do. The right side is a little confusing, because now I have 2 minus the square root of x times 2 minus the square root of x. Remember, we can't just square 2 and square root of x and put 4 minus x. That doesn't work that way. So this one here, to FOIL, I'm going to do the same thing we do first. Terms are going to be 4, 2 times 2. Then I have minus 2 square root of x. And here I have another minus 2 square root of x. And then these two right here, square root of x times square root of x is x. Negative times negative is positive, so plus x. So x minus 2 equals 4 minus 4x, or 4 square root of x, plus x. The square root of 2 times square root of 2 square root of x plus minus 2 square root of x is minus 4 square root of x. Now I want to simplify. Well, what I need to do, I notice I still have a radical symbol in my problem, so I go through the steps again to isolate this radical. So sometimes it works out nicely. This one I can subtract x from both sides, and I cancel, and I get 2 equals 4 minus 4 square root of x. I need to get rid of this 4 first, and then this one, so I'm going to go, because you always get rid of things farthest away first, minus 4 minus 4. These 4 minus 4 is 0. That's going to be negative 2 equals negative 4 square root of x. And then the last step would be to get rid of this negative 4 here. Okay, to do that, I'm going to divide both sides by negative 4. This cancels, and I have 1/2 equals the square root of x. So now that the square root is isolated, I can square both sides again. So I square this side, and I'm going to square this side. 1/2 times 1/2 is 1/4 equals x. And I look at that and say, well, wait a minute, that seems kind of strange. I'm not sure if that's going to work. Let's check to see. We're going to put at 1/4 into our x's up here and here. So this becomes in our check portion to make sure it works. The square root of 1/4 plus 2 equals 2 minus the square root of 1/4. And while we're not comfortable always with fractions, they're part of our lives, we need to figure that out. So 2 plus 1/4, I'm going to do that in fraction form. That's going to be 1/4 plus, to make this denominator 4, that would be 8/4. And that's going to be 2 minus 1/2, because the square root of 1/4 is 1/2. So these two fractions add together to be the square root of 9/4 equals 2. Well, 2 can be written as 4/2, that's 2, minus 1/2. The square root of 9/4 is the square root of 9 over the square root of 4, which is 3/2, which equals 3/2. That checks. This is my answer to that confusing little problem. Okay.